So welcome once again. So we will discuss as in remaining part of light. As I promised, I am back after half an hour. So I thought probably I'll do it today only, so you guys will be beneficial. Okay. So light is a very important chapter. As you said, you have seen already and I'm trying to conceptualize everything within 30-40 minutes. But light is the big chapter basically, and a lot of small nitty-gritty concepts are there which need to be understand very well. Okay, now we have seen already reflection of light. Now this time we will read the refraction of light. Okay, so reflection and refraction, the difference normally in the reflection we said only one medium, rather it is the two medium. Okay, so basically it is the phenomena of change of path of light when the light goes from one medium to another medium. When the light travel from one medium to another medium, okay, so it's changes path. So I show you the example. Suppose this is one medium, okay, and this is air, and this is say water, okay, and this is again air. So and this is normal, as I said. So when the light rays fall here in the air medium, so when it goes to water, it bends towards the normal. So this is incident ray, this is refracted ray. Okay, so you see this is one medium, okay, or water or glass, anything you say. So water, but it has to be transparent medium. This cannot be opaque. Okay, so when the light pass from one medium to another medium, this is medium 1 and this is medium 2. So if you see, the light is have bent towards the normal. This is normal, this is normal, this is incident ray, this is refracted ray. And what is the basic cause of refraction in change in speed of the light going from the one medium? Okay, so this is the basic cause. This basically what is happening, it is changing the speed of the light. Okay, uh, rather other wavelength and frequency remain same. Okay, now this basically the way we have law of reflection, we also have law of refraction. So what is law of refraction? Again it says the incident ray, the refracted ray and the normal to the incident of two transparent medium at a point of incident all lies in the same plane or the same point. So here you say all is there. So here is, if you say incident ray, refracted ray and the normal, all lies into the same plane. Okay, on the same plane, or you can also say this lies in the same point. Fine, I hope this is clear. Okay, now again, speed of the light, I would say that the light travels faster faster in rear medium, okay, and light is slow in denser medium. So in denser medium light is slow. Okay, so and we know that speed of light, what is the speed of light for y'all? So speed of light is what? It is 3 into 10 to the power 8 meter per second, and it is denoted by c. Okay, so this is very important what I'm tracing. I just put a little. And speed of light in glass, water, it is this in speed of light in air or in water is 3 into 10, no, water it is 2.25 meter into 10 to the power 8 meter per second, and in the glass it is 2 into 10 to the power 8 meter per second. Fine, so this is speed of water as far as concerned. Now coming back to the reflection of light, the incident ray, the reflected ray and the normal, they all fall into the same plane. Okay, So this is the refractive index. Now the other one is also known as, the other law is also known as that the Snell's law. So sometimes the question asks Snell's law. So Snell's law, it is nothing but the second law of reflection. So it says the ratio of sine of angle of incident. Okay, so sine of ray of incident is and to the sine of refraction. So it is basically sine I upon sine R is equal to constant. Okay, so since it is normally, and the Snell's law says that the product of the refractive index and the sine of angle of incident at a point in a sine of medium is a constant. Okay, fine. Okay, so second is we will discuss. So we discussed reflection of light, we discussed the speed of light, we saw whether light is faster, very slow, we saw two laws of reflection, we also discussed the Snell's law. Now next is the important concept which basically very much related to the Snell's law and the law of refraction. Okay, so what that concept is called? Refractive index. So what is refractive index? It is the represent the amount of extend the bending of light when this passes. So as I say, if I says when the light pass from one medium to other medium, it either is move away the normal, okay, or it's moves towards the normal. So it's depend upon how the medium is. If it is denser and this is rarer, so this condition, if it is rarer and this is denser, this condition will happen. Okay, so it means when the light moves, so this is called how much the light will bend, it is called refractive index. So there is a two concept basically, what is relative refractive index, another is absolute refractive index. Okay, so relative refractive index is with respect to other medium. Okay, refractive index of medium, of medium 1 with respect to medium 2. Okay, please note that what I'm saying, refractive index is basically, it is the it is the it is the measurement of bending of light from between two different medium. Okay, so refractive mediums of medium 1 with respect to medium 2 is basically, we'll say the speed of light in medium 1 with respect to speed of light in medium 2. Okay, how the speed of light behaves in medium 1 and medium 2. Okay, so if I say one written as refractiveness of medium 1 with respect to medium 2, then I say what is medium 1, what is medium 2 refractive index. If I say the refractive index indicate by n, then I say refractive index of 1 with respect to 2, so n1 by n2. And what I say, velocity speed of light in medium 1, so speed of light in medium 1, again it is, what is that? It is velocity of light on c upon in medium 1, and then velocity of light in medium. So we say n1 by n2 is equal to c by v1 upon c by v2. So c cancel, v2 upon v1. Okay, so refractive index is basically, it is the basically measurement of bending of light between two medium. Now what is absolute is a little different. So absolute, when you talk about the absolute measurement, okay, so it is when we talk about absolute refractive index. So in that case basically we saw the speed of light in vacuum with respect to speed of light in uh, in the medium. Okay, so I hope this concept is very clear. So we have to understand the concept. Okay, this concept is very important because a lot of questions they are normally asked in this particular this particular uh, chapter. Okay, so now let's comes to so some of the formula which is very important when it comes to refractive index. Okay, and a lot of numericals being asked in this particular portion, है so what are the numericals normally they ask? So they give the refractive index of 1 with respect to 2, and then when you have to find the absolute refractive index, so absolute index of light, so if it is n, then we say it is the speed of light in vacuum or air divided by speed of light in medium. Okay, so it is C upon V. Okay, and these both are measured in meter per second. Please note that refractive index has no unit. So they ask this question, what is the unit for refractive index? Then say it has a no unit. Okay, okay, now this we have already seen. Now let's move to lens. So what is lens? So lens are the transparent refractive mediums bounded by two surface. Okay, they are bounded by two surface, and they are of two types. So one is called convex lens or the converging lens. Another is concave lens or the diverging lens. So how the convex lens looks like? The convex lens looks like this is convex lens and this is concave lens. Okay, so I'm sorry, my drawings are not very good. I apologize for that. Concave lens. Okay, this is concave lens. So it is thin from the middle and thick from the edge, and this is reverse of that. Okay, and some terms we will discuss as we did, so related to concave and convex. So I'll put the bigger picture of concave and the convex and the concave, and I'll show you some interesting concept. Okay, and this is the middle. Suppose these are the normals, right? So if it is normal, so the light basically from center of curvature is passes, so it is again, so it is the optical center, so there is no reflection. Okay, so this is C, this is C, this is center of curvature of is bounded by two lanes, I said, right? So it is bounded by two lanes. So this is C1 and this is C2. Similarly, this is the C1 and this is C2 for the other lens. Fine. Okay, and this is PQ, this is P dash Q dash. Okay, now this is called principal axis. So the pole is the center of the mirror is called pole. Okay, so center of the mirror is called pole. Okay, fine. It is a central point of the mirror. What is center of curvature? So center of curvature, the center of sphere of which the mirror is part is called center of, is the same, it is denoted by C. Okay, so center of curvature is called like here is C, C1 and C2 and C dash 1, C dash 1 and C dash 2. Okay, so what is radius of curvature? Okay, any idea what is radius of curvature? Okay, so it is passing through the pole, and the center of curvature is called the principal axis. Is the imaginary line, straight imaginary line passing through the center of curvature. Okay, and the pole. Okay, the straight line passing through the pole and okay, and the center of the curvature is called principal axis. Okay, what is optical center? The optical center is a point on the principal axis of lens such that a ray of the light passing through goes undeviated. It is undeviated. It do not deviate. Okay, I hope this concept is clear. Okay, and what is the first principal focus? So first principal focus, if I say, the first principal focus is, so if I take the example of, so for concave and convex, say I said if it is, say, okay, so this is the normal. Okay, so this is f1, and so when this goes here, after reflection it will be the parallel to this axis. Similarly, it will be parallel to principal axis. This is principal axis. Okay. So here what I say, principal focus of the lens of the point on the principal axis for which the imaginary, where the image is formed at the infinity. Okay, so distance C f1, so this is C, so C f1 is called the first principal focus. Similarly, if you take the other way, if I take the other picture, I'll make it little smaller. So if the rays parallel to the principal axis, if it is parallel to principal axis, so it after the reflection it will meet here in, this is f2. Okay, and this is called here cf2 is equal to focal length. Okay, so the second focal length is the position of image point on the principal axis of the lens when the object is situated at the infinity. Okay, so I hope these two are clear. So this is the law we have already discussed. Okay, so these are the first principal focus and the second physical in case of the convex lens. Okay, so for convex lens, okay, so in convex lens f1 f2 are the real point. So point it, this f1 and f2 what we have discussed, whether is in concave. Okay, so if I take in concave, so if I take the principal axis in concave, so suppose if I make concave, I'm sorry, let me draw it nicely for you. So this is the normal. Okay, so when the rays comes here, it will be parallel to the principal axis. Similarly, when the other ray comes this side, it will be, now it appears to meet, as I said. Okay, so this is f1, and if I take, if I say if it is passing through the principal focus, then how it behave. So this is normal, fine. If it is parallel to the if it is parallel to the principal focus. After the reflection it will diverge, okay, and when we extend the line which is diverting, it will meet in the f2. So these are principal axis, these are principal axis. Okay, so in the convex lens, in case of convex lens, okay, it is the real point, okay, but in case of f1 f2 is the virtual point. So these are the virtual, basically it doesn't, here is exactly meeting, okay, so that's what it's at the real point, and here it is the virtual point. Okay, so but you have to remember the f1 and f2 is the same. Fine. Okay, now for the convex lens, the following three special kind of rules basically they follow. Okay, uh, any two of these special rays. So what it says this, that the rays incident on the lens in the direction to principal axis, on direction they passes through the second principal axis as we see. Second bit says rays passing through the optical center is straight undeviated, and third says the rays passing through the principal axis of convex lens after the reflection will emerge parallel to the principal axis. So we have seen, so first we have seen already the lens is direction parallel to the principal axis. Okay, we have seen here in convex में we have seen which is parallel to, I will again draw, we have, you see it here, if it is parallel, so after the deflection they are meeting here. Second, if it is if it is emerging through, if it is emerging through focal length, okay, so after reflection that will be parallel to the principal axis. That's what it's saying, it's nothing new. The ray incident on the lens in the direction parallel to principal axis on the lens in case of convex lens, on reflection they passing through the second principal focus, we have seen already. Second, the rays passing through the optical center of the lens passing straight undeviated, okay, and rest we said rays of the light passing through the principal focus of the convex lens after reflection will emerge parallel to the principal axis, emerge to the principal axis. See, this is fine. So I hope you are remembering this thing in your exams in the long answer. Now as we discuss in the case of refraction, the refraction also has some point, okay, so they have points like how the image looks like. So summary of the characteristic of concave mirror, so whether it is infinity, so here if you see both the table compare to each other in case of concave and convex lens, if you compare different condition, so if it is, suppose is, if I take the first condition, if it is, if it is in the infinitive, so as I said it is parallel, so it will, after the reflection it will move here, and the third one they will meet here. So this is the first case, so this is the parallel, this is parallel, don't take it, this one is parallel. So the first one, if it is infinity, so it will meet at the focus. Second, if it is beyond 2f, so this is the first condition, okay. Second condition, if it is beyond 2f, if it is beyond 2f, this is, so this is f1, this is 2f1, okay, and suppose it is here, so what happened if it is a parallel, sorry I'll put it the normal, so if it is parallel to principal, after the reflection it will pass through the principal focus f2, and it will, this is f1, so somewhere middle it will somewhere in the middle, it will make the, somewhere in the middle it will, so image will form here, okay. So please follow, as I said earlier also, the NCRT or any good book in order to see the diagrams, okay. This is for your understanding I'm drawing. Second one, third one we have discussed, this is the second one. Okay, now third one, it says if it is at 2f. So now it is here, means it is here means, so suppose it is f1 and it is f2. Okay, 2f1, sorry, 2f1, it is 2f1. Okay, so and if this is an object, so when it is parallel, okay, after diffraction it will go to, it will pass through f2 as usual is happening in every case, f2, and it will, so the point where it will meet, this point to it is nothing but it is 2f2. Okay, okay, it's 2f2. Okay, so this one. So similarly, if it is between f1 f2, it is beyond f2 and it is size. The most important thing you have to remember how the size of the image. So if you say highly reduced, initially is highly reduced, so this pattern is remain same. If you see the our reflection, you compare, so only in case of, so if you remember one, you can remember others. How you can remember one and you can remember others? So if you remember the first one, I have what I have discussed here, it was same, it was infinitive. Here in case of 2f1 it was c, in case of 2f, so 2f1 is c in case of reflection. Okay, f1 and 2f1, then it was between c and f. Okay, so it was between, it is f is f, 2f1 is c, so c again it is f. Okay, and this is the last one is between poles and the middle. So if you remember, and rest it is all same, diminished, equal, enlarged, highly enlarged, enlarged, and all are same. So if you remember one of the table of the reflection or the refraction, you can reproduce the other one very well. So at the focus it is f1. So this was the compare I gave you with the reflection. So with the reflection we say this is center of c. Okay, center of curvature. Okay, so now here is we discussed already this point. Okay, so it is erect, this is erect. Okay, so I hope this is clear. Okay, now so this table you have to remember, now between c and f it is behind the f1. Okay, so this I would like to draw for you. So when I say this one, so when it is between, so it is enlarged. Okay, it is behind the, between c and f it is behind, it will, so I will discuss this one. So before that I'll produce the this is one easy, this is the condition. Fifth condition I would like to produce, and then I'll draw the sixth one. It will somewhere here and it will pass through, so it will never, it will always parallel. This is f2, this is c, optical center, this is f1. Okay, and the last one, which is very important, the sixth one is, this is, okay, so if it is, this one is, so if you see, so it will be after reflection, it will goes through, this is f2, and this pass through center of curvature, and you can see it here, your eyes. Okay, so but when you see it, so these two, when you extend this dot, okay, so here is your image, this is your image. So that's what is said, it is called behind f1, this is called behind and that is the only condition when it is virtual and erect. Rest all are real and inverted. Same way it is there in the reflection. Fine. I hope this is clear to you. Now, similarly, concave, you follow the image from the book. These are only two conditions the way we have in the reflection of the light. In one condition, the image will form at the focus, and second it will be between P and M, principal focus, a pole and focus, okay, and which is behind the mirror, okay. Okay, so second is between the focus, okay, and at the infinitive at the focus, second is between the optical center, pole and optical center, okay, fine. Huh? So this is at the infinitive, this is between optical center and the infinity, okay, and this will be diminished, we can say highly diminished, much smaller object, okay. So the virtual erect, and the position will be between this will be between, so I'll draw it, it is between okay, okay, fine. Now we'll discuss the lens formula. So what is the lens formula? So lens formula says that the similarly what we have learned in the lens formula, it is says an equation which is represented between relationship between the focal length, lens, object and image distance is called lens formula, okay. The lens formula is what is the lens formula, if you remember? So the lens formula says that 1 by V minus 1 by U is equal to 1 by F. Okay, now the lens formula for both concave and convex is same, okay, but only you have to remember the convex lens forms a virtual image where the object may be, okay, and convex lens may is the real. So it is the only difference of the is the virtual image is the real image, okay. So note the lens formula in is the same for both the convex lens and the concave lens, whereas in the convex lens forms a virtual image wherever the object may be, okay, and in case of convex lens is may be, okay, on the real image, which is depending upon the position of the object, okay. So lens formula is not changed by nature of the image or by the change of nature of the lens, fine. Okay, so lens formula where u is your, so in case of English we want to write, so it is 1 by V minus 1 by U, so means 1 by image distance minus 1 by object distance is equal to 1 by focal length, fine, okay. So now similarly that here also we have a Cartesian product, okay. So all the distance measured, all the distance, so here if you say Cartesian product, so all the distance, fine. So the left side object is always positive, upright, this is object always positive, okay. Image is downward, always negative, image always taken negative. So this is taken positive, what is that? Direction of incident ray. So anything which is in direction of incident, and anything which is reverse the direction of incident ray, reverse incident ray direction, it is taken negative, okay. Similarly directions along the direct direction along incident right is positive, okay. So this thing you have to remember, all the direction measured from optical center, the direction measured in the direction of incident is taken as a positive, the height is always objective, okay, and uh, the image is negative. Okay, so this is we have to remember this one, the Cartesian sign convention. Okay, particularly, so these words along, direction of, these words you have to figure it out when you fix the numerical problem. Okay, now the last point is linear magnification. So what is linear magnification? In case of lens, the linear magnification is produced by lens is the ratio of size of image through the size of the object. It is size of image upon size of object. Okay, size of object is, it is I by O. Okay, and this is also known as 2 by H1. If you remember what we have discussed in the our this one, on the reflection side. Okay, so for convex lens, linear magnification can be less than 1, equal to 1, or greater than 1. So magnification for convex, so m can be equal to 1, m can be greater than 1, or m can be equal to 1 or greater than 1, less than 1. Okay, but in case of, this is convex. Okay, but in case of concave, linear magnification always less than 1, always less than 1, oh sorry, always less than 1. Okay, that's fine, I hope. So linear magnification is not very much is there in the uh, to be stressed upon. And the last topic of light is power. There's lot of questions they ask, 1 marker, 2 marker. Okay, so the power of lens is the reciprocal of P. Okay, so reciprocal power of lens is the reciprocal of the focal length of the lens. So power of lens P is equal to reciprocal of focal length of lens, which is F. Okay, and if focus is M1, power is 1 diameter. Okay, then we say if F is 1 meter, power is 1, and it is measured in diopter. Okay, the SI unit of power is diopter. It's very important, and I'm sure this they're going to ask you in the exam. It's diopter. Okay, so 1 diopter is 1 diopter. Then what? How can we say? P is equal to 1 by F. Okay, so is 1 by 1. This is 1. So how do we find out the 1 diopter? If focal length them, power is 1 diopter. Okay, fine. So I hope this is very clear. And usually lens is given in the centimeter. So if now lens is given in centimeter, therefore P is equal to 100 by F centimeter. Okay, so I try to concise everything into 30-40 minutes, but it's a big chapter. Read through my videos again, Anna, and subscribe us. Okay, and I hope this will help you in getting good marks in your exam. I'll again come with the other chapter tomorrow, which is electricity or magnetism, depending which is available. Okay, thank you very much, and keep watching, subscribe us, like sessions. Okay, so I can create more and more good live session in video for you.